Hello class, in this video, we are going to review for exam 3. First question, using the factoring method to solve for the roots of the quadratic equation. Be sure to place the equation in standard form before factoring. Check your answer. Let's look at the equation here. The equation is x squared plus 7x plus 12 equals 0. It is in the standard form already. Right side of the equation is 0. Left side is a quadratic equation, quadratic trinomial with leading coefficient 1. So we can use the shortcut method to find the two numbers, multiply to 12 and add up to 7, right? Both of them supposed to be positive numbers. Which two positive number? We have 1 times 12, 2 times 6, 3 times 4. Obviously, it's 3 and 4, right? 3 and 4 multiply to 12, add up to 7. So the solutions of the equation are 93 and 94. Use a comma to separate answers as needed. So we have two solutions. We're going to enter 93, comma, 94. Okay, next. Question number 2. Use the factoring method to solve the quadratic equation. Okay, this one is a little bit more complicated. It is 25x squared minus 2x plus 9 equals negative 32x. So this equation is not in the standard form yet. We need to rewrite the equation in the standard form. To do that, we add 32x to each side of the equation, all right? Then we have the right side equals 0. We cancel. The left side becomes 25x squared, negative 2x, positive 32x. That gives 30x. Bring down 9. Let me adjust the equal sign. Look at the coefficients, 25, 30, and 9. There's nothing we can factor out. GCF is 1. So we are going to apply slide divide method. Slide. We have x squared plus 30x plus 25 times 9. 225. All right? It's basically 15 times 15. Yeah. Okay. And then we can apply the shortcut to find the two integers, multiply to 225 and add up to 30. The two numbers must be both positive. So this one is pretty straightforward because 225 is a perfect square. 225, in fact, is actually, this trinomial actually is a perfect square trinomial. Yeah. So we can use the slide divide method. Yeah, since I'm already here, let me continue. We have 15 times 15, 225. 15 plus 15, 30. And then we're going to divide the two numbers by the original leading coefficient 25. Simplify. We have x plus 15 over 25 is 3/5. Same with here. X plus 3/5. 3/5 is in red. So the equation actually have two solutions, but the two solutions are identical. They are negative 3/5. All right, negative 3/5. As I mentioned, in fact, the equation the left side of the equation is a perfect square, 25x squared plus 30x plus 9 equals 0. If you can see, this is a perfect square with base 5x. This is a perfect square with base 3. And the middle term happens to be twice of the multiplication of the two bases. 5x times 3, 15x, double the 30x. So the left side can be factored by using the perfect square trinomial formula as the square of 5x plus 3, okay? If the perfect square equals 0, the base has to be 0. And then we solve the base equals 0 minus 3. We have 5x equals negative 3 divided by 5. We have x equals negative 3 over 5. Same with the result, same result with earlier, right? So you can use the slightly divided method, but if you can identify the left side of the equation is a perfect square trinomial, you could also applying the factoring method to solve it, all right? Yeah, you will have the same result. The solution is a negative 3/5. Negative 3/5. Double check your entry. Negative 3/5, right? Okay, next. Question number 3. Factor by any method, all right? Let's look at this trinomial. 39x squared plus 10x minus 1. Since the constant term is negative, it's not a perfect square trinomial. So the formula method is not in the picture. And we should also look at the GCF, right? GCF obviously is 1, so nothing can be factored out. Then let's do slide divide slide method. Slide divide slide method. Okay. Slide, and then we have x squared plus 10x. 39 times negative 1, negative 39. Factor. Which two numbers multiply to negative 39 add up to 10? The two numbers must have opposite sign, right? Think about 13 and 3, I think. Positive 13, negative 3. Yeah, you go through the process, you can find the two numbers. Positive 13, negative 3, multiply to negative 39, add up to 10. Okay? And then divide. Divide the two red numbers by the leading coefficient 39. Simplify. 13 over 39. Just keep using the black color. 13 over 39, 1/3. If you are not sure, use your calculator to assist you. 3 over 39, 1 over 13. Yeah, since we still have the denominator, we're going to slide in front of the variable x inside each parenthesis. So the factorization is 3x plus 1, 13x minus 1. That's the factorization we need to enter in the cell here, okay? Parentheses, parentheses. I think I probably need to make it smaller because, yeah, couldn't see. In the first parentheses, we have 3x plus 1. Second parentheses, we have 13x minus 1. Double check the result. 3x plus 1, 13x minus 1. Okay. Question number 4. Factor by grouping. Check your answer. It's been a while, right? Yeah, but I believe you remember the process. We apply grouping method to factor polynomials with 4 terms. AB minus 9A plus 8B. That one is AB. This one is 8B minus 72. Double check you copy everything correctly. And then we're going to group the first 2 terms, the last 2 terms. Factor out the GCF. AB, 9A, GCF is A. Factored out, we have a B minus 9 in the parentheses. The second group, 8 b minus 72. GCF is 8. 8 goes into 72 9 times. 72 divided by 8 is 9. So in the parentheses, we have b minus 9 also. We want the two parentheses have the same binomial, right? Yes, we do. We have a common binomial factor factored out, b minus 9, and the leftover, a plus 8. A plus 8. The same thing. Letter A plus number 8. So the factorization is b minus 9, a plus 8. First parentheses, b minus 9, a plus 8. Double check your entry, b minus 9, a plus 8. Okay, next. Factor, if possible, check your answer by multiplying. All right, this polynomial has 4 terms, right? Select the correct choice below. So this is a multiple choice question, okay? All right, let's see how do we factor it. Let's see if we are able to factor it, okay? It has 4 terms. Ax minus 3cx and plus 5ay minus 15cy. Double check. Ax minus 3cx plus 5ay minus 15cy. If we group ax, yeah, let me see how do I group it. A minus 3c. Yeah, it is factorable by grouping. We can factor it by grouping. So ax minus 3cx, first group, 5ay minus 15cy, second group. There are 2 terms in the first parentheses. GCF is x, factored out. We have a minus 3c. Second group, 515, GCF is 5. We have y in common, right? So GCF is 5y. Factor 5y out, we have a minus 3c inside the parentheses. Double check if you are not sure. 5y times a, 5ay, 5y times a, 3c, nearly 15y, cy. Okay, everything looks good. So we are going to factor out this common binomial factor, a minus 3c, and left over x plus 5y. All right, enter the answer here. Is factorable. Is factorable. The result, parentheses times parentheses. In the first parentheses, a minus 3c, a minus 3c. Second parentheses, x plus 5y. A minus 3c, x plus 5y. Okay, next. Question number 6. Factor by using the perfect square trinomial formula. Okay, when the question requires using the formula, that actually reminds you or tells you the trinomial that is given is a perfect square trinomial. So we don't have to even check, right? And look at the first term and last term. The first term, 36x squared. 36x squared. So the base is 6x. Base is 6x, right? In the middle, we have a plus, so we have a plus in the parentheses as well. 49 is the square of 7, so plus 7. And then raise the binomial sum to the power of 2, right? Yeah, this kind of problem actually is pretty straightforward. It's asking you to factor the trinomial using perfect square trinomial formula. Basically, it's admitting this trinomial is a perfect square trinomial. So you only need to find the 2 bases, 6x and 7. Add them up. The reason we add them up because the middle term is positive. And then raise the parentheses to the power 2. Question number 7, factor by first look at the GCF. Okay, it is a binomial. 243 x squared minus 3y squared. That is a very good reminder. The GCF of the binomial is 3. Let's factor it out. We have 81 x squared minus y squared. Yeah, 81 times 3 is 243 minus 3y². Okay. Inside the parentheses, we have a difference of two squares. 81 is 9 squared. X squared is the square of x, right? So 81x squared is the square of x. And y squared. So we can write the difference of two squares. So that you should write base 1, base 2. Yeah, try not to skip this step. Inside the parentheses, I'm talking about inside this red parentheses, we have a difference of two squares. The first base is 9x. The second base is y. And we have the difference of two squares factored as base 1 plus base 2 times base 1 minus base 2. This is the final answer, right? Let's enter in the cell. We have a 3 in front. First parentheses, 9x plus y. Second parentheses, 9x minus y. Okay, let's see. 3 times parentheses, 9x plus y, 9x minus y. Okay, next. Question number 8. Factor if possible. Check your answer by multiplying. Yeah, I see it already. This is a quadratic trinomial with a leading coefficient 1. Shortcut method applies, right? A is 1, B is 12, he is 27. So shortcut methods applies. We need to look for two integers multiply to 27, add up to 12. They should be both positive because they multiply to positive, add up to positive as well. Which two positive number? Let's factor 27. We can do 1 times 27, 3 times 9. You see it already, right? If you want to continue, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7, 8 don't work. We only have two ways to factor 27. And has to be this one, okay? Positive 3, positive 9. Yeah, because those two numbers multiply to 27, add up to 12. So the result is x plus 3 times x plus 9. Enter the answer here. X plus 3, x plus 9. Okay, oops, just want to double check. Yeah, x plus 3 times x plus 9. 3 times 9, 27, 3 plus 9, 12. You should always double check, okay? Make sure the two numbers in the two parentheses multiply to 27, which is C, add up to 12, which is B. Next, question 9, factor by grouping method. Just forget it, okay? We only use grouping method to factor polynomial with 4 terms in it. We can use, let me see. We can use slide divide slide method for sure. This one, 10x squared minus 29x plus 10. GCF is 1, right? 29 actually is a prime number. Slide x squared minus 29x plus 100. Can we factor this trinomial by shortcut method? Yes, because the two integers multiply to 100, add up to negative 29. The two numbers are going to be both negative, okay? Which two negative number? Negative 25 and negative 4. Negative 25 and negative 4 multiply to positive 100, add up to negative 29. And divide the two integers by leading coefficient 10. Don't forget to simplify it. 25 over 10, 5 over 2. 4 over 10, 2/5, right? 25 divided by 5 is 5, 10 divided by 5 is 2, 4 divided by 2 is 2, 10 divided by 2 is 5. Okay, and now we're gonna slide it back. 2x minus 5, 5x minus 2. Done. Enter the answer here. Yeah, we use the slide divide slide method. 2x minus 5 5x minus 2. 2x minus 5, 5x minus 2. Okay. Question number 10. Factor by grouping. Yeah, this one we use grouping because the polynomial has 4 terms. AB minus 7a plus 3b minus 21. AB minus 7a, group 1, 3b minus 21, group 2. Factor out a, AB, negative 7a, GCF is a. Inside the parentheses, b minus 7, 3b minus 21, GCF is 3. Inside the parentheses, b minus 7. We factor b minus 7 out, we have a plus 3 inside the parentheses, and that is the factorization of this polynomial. Factoring by grouping. We have a b minus 7. Here is a plus 3. b minus 7, a plus 3. All right? Okay, so I'm going to stop here, and I'll see you in the next video.